Hello everyone, welcome back to A4 Analysis. This is the second episode of Study Statistics with me. So today is a brief overview in Descriptive Statistics. We will go through few of the important terms and their formulas. So first let's talk about measure of central tendency. So measure of central tendency is a type of measure that can be used to describe a set of data. And it gives us information about the center or middle part of a group of numbers. So a group of numbers or data or data set, whatever we want to call it, we would be discussing about where the middle part is uh, standing and what does it tell about the data set or the data. So this is actually a small part of code which we'll come back to probably in few moments. Let's first see few of the terms that we used in measure of central tendency or in descriptive statistics. So the first one here is mode. So it is the most frequently occurring value in a set of data, and where there is a tie for the most frequently occurring value in the data is called bimodal. And if there are more than two modes, then the data is called multimodal. So let's go back to our example. Here, as you can see, this is the data set we have. It's a really small data set. And as you can see, if we take the frequency for each value, 1 is appearing just once, 2 is appearing just once, 3 is appearing just once, 4 is appearing twice, 5 is appearing thrice, 44 is appearing just once, and 99 is appearing just once. So if we think about the frequencies, the most frequent number in this appears to be 5. So that's how you can see that the mode is 5 here. And if you would have had a number of 5 as 3 and number of 4s as 3 as well, here now in this data set it is the frequency of the number 4 is 2, but if it was 3, in that case we would have had two modes and you would have got 5 and 4 as your mode. Next we have median, which is the middle value in an ordered data set. Now if you look at this, this is not ordered, and if you order this and then you see the centered, or if it is say for example if you have 2 in number of data points, if you are looking at the center, whatever value you will get will be the median. Now there's a catch. If there are 2 in number of data points, you would get 2 middle points, right? So in that case you have to take the average of those 2 middle points. But in case you have odd number of data points, in that case you will find the exact middle point and you don't have to take any average anymore. And that would be the n plus 1th. N plus 1 by 2th will be the index of the middle point. Then we have mean. Mean is, of course, we are talking about mean from probably our childhood. Mean is the average of all the data points. So population mean is where you take the summation of all the values and you divide it by the population size. And sample mean is when you are taking summation of all the values in the sample, all the data points of the sample, and then you are dividing the summation by the size of the sample. So population mean is denoted by mu and sample mean is denoted by x bar. Then we have percentile and quartile. Percentile is the measure of central tendency that divides a data set into 100 parts, and quartile is also very similar except it divides the data into 4 parts. So these things will come handy while doing different types of analysis, and we'll see this in the upcoming episodes as well. And there is interquartile range, which tells you the difference between the third quartile and first quartile. So if you know the values of your third quartile, and if you know the value of your first quartile of a particular data set, then just by subtracting first quartile from third quartile, you will get the interquartile range, which is IQR. Sometimes it is called IQR. It is Q3 minus Q1. Now, if it is ungrouped data, then we have range. So range is basically nothing but it is the difference between the largest value and the smallest value in the data set. Now let's talk about the other measures of variability in the data. So we have deviation from the mean. Deviation from the mean is nothing but for each data point, we can take the difference from the value of that data point and the mean of the data set, and that would be the deviation from mean. Now let's talk about the variance, which is also another popular term. We use it all the time, and variance is the average of the squared deviations. So first we talked about individual deviations from the mean, but if we take all the deviations, if we take the squared sum of all such deviations and we divide it by the total size of the population, then we would get the population variance. And if we do the same thing where it is for the sample, a small sample, then we would call it not population variance, of course, it would be the sample variance, and it would be denoted by S square. And if it is population variance, we would be denoting it with sigma square. Next is standard deviation, which is nothing but the square root of variance. So it is the same formula. Again, we are coming from variance and we are just taking the square root. For population, which would be denoted by sigma, and for sample, it would be denoted by S. Next, we have when we are talking about statistical standard deviation, actually, we would be also talking about empirical rule. So there is a rule of thumb that is used to state the approximate percentage of values that lie within a given range of standard deviation when the data is approximately normally distributed. So what does it really mean? Empirical rule tells us how much percentage of data is lying in which range in terms of standard deviation. So let's look at this graph and try to understand what empirical rule really means. So this is a normally distributed data set, and as you can see, it has mu, or the mean, exactly in the middle, and it is normally distributed. It is a symmetric distribution, and this -1 and 1 are actually, this is minus one standard deviation, and this is +1 standard deviation. So it is just showing the relative this is mu, this is 1 standard deviation, this is 2 standard deviation, and this is 3 standard deviation, and so on. So what empirical tool is telling is keeping mu, or keeping mean, as in the center. If we take the range from -1 standard deviation to +1 standard deviation, in this range 68% of the total data would lie in this range. And if we broaden this range from -2 to 2 standard deviation, the percentage of data would become 95%. And if we take even a broader range from -3 to 3 standard deviation, of course the mu is in middle, then we would be covering 99.7% of the data of this distribution. So that's about the empirical rule. But one thing that we have to remember in this case is the data is approximately normally distributed. So what do we do when the data is not the data is not normally distributed? Of course, we still have a way to solve that issue. We would be using Chebyshev's rule. So Chebyshev's rule would be used when the data is not normally distributed. So it is telling that at least 1 minus 1 by k square values will fall within plus minus standard deviations of the mean, irrespective of the distribution of data. So here we saw that 68% data was lying between plus minus 1 standard deviation within this plus minus 1 standard deviation range. Then 95% data was lying between plus minus 2 standard deviation, and 99.7% data was lying between plus minus 3 standard deviation range. But here we are making it as 1 minus 1 by k square values will lie between plus minus k standard deviations of the mean, and we are not restricting it with the normal distribution anymore. Next is z-score. Z-score denotes the number of standard deviations a data point is above or below the mean of the dataset when the data is normally distributed. So z-score will actually give you a relative distance from your mean, not from your mean, from the dataset's mean. It will tell the relative distance of that data point from the mean of that dataset in terms of standard deviation. So first we are taking the distance between the x, which is the data point, and we are subtracting mu or mean from it, and after that we are dividing it with standard deviation. So actually whatever value we are getting here as z-score of the data point is in the unit of the standard deviation. So how many standard deviation away or up or below it is from the mean of the dataset. Coefficient of variation, it is the ratio of the standard deviation to mean in percentage. So it is nothing but, first on the top we will have standard deviation as the numerator, and the denominator will be the mean of the population, and it's of course a ratio, and we are just multiplying it with 100 to make it as a percentage, and that's what we will be calling as coefficient of variation. Next we have measure of shape. We have skewness, and skewness will help us understand the relationship between mean, median, and mode of that distribution. A data set is called to be skewed when its distribution is asymmetrical. So when our distribution is symmetrical, we don't have any skewness. Our skewness coefficient will be 0, and mean, median, mode, everything will overlap. But when it is positively skewed, as you can see, it's not overlapped anymore and the values are different. Here as well, as you can see, this will be a negatively skewed distribution, and mean, median, mode are not overlapping anymore. They have separated. Next we have kurtosis. Kurtosis is the amount of peakedness of a distribution. So whether it is thin and tall, whether the distribution is thin and tall, or whether it is flat and spread, or whether it's in the middle, is described by the term kurtosis. So high and thin distribution is called as leptokurtic distribution, meaning narrow, and there is one distribution which is flat and spread, which is called as platykurtic distribution, and the one which has moderate peakedness is called mesokurtic distribution. So that's all about today's chapter. It was just a quick review. We'll be back very soon. So if you found this video helpful, please give it a like and comment what next you want to see in this channel. We'll meet again very soon. Bye guys.